Hello, everyone. Today I'm to talk about selection sort. So let's look at this list. It has index 0, 1, 2, 3, 4, and in index 0, it has value 29, and index 1 it has value 10, and etc. So for selection sort, we find the smallest element in the entire array. Let's say we scan this list, 29, 10, 14, 37, 14. The smallest is 10. So we swap 10 with the leftmost element, which is actually 29. Now the array looks like this. So remember, in selection sort, we have the sorted part and the unsorted part. So the sorted portion is 10 right now, and this unsorted portion is 29, 14, 17, or 37, 14. Now we ignore the first element, which is in index 0, because that's been sorted, and look at the elements from index 1 to 4, which is 27, 14, 37, 14. The smallest is 14 at index 2. So we swap the 14 with the leftmost unsorted element, which is 29. And then the array is now 10, 14, which is the sorted portion, and 29, 37, 14, which is the unsorted portion. And we do the same thing again. We look at the unsorted portion of the list. Now, index 0 and 1 are sorted. And now we look at index 2 to 4, which is 29, 37, and 14. And the smallest is 14 and index 4. And we swap 14 with the leftmost unsorted elements, which is 29 and index 2. Then the array becomes 10, 14, 14, 37, and 29. And now index 0, 1, and 2 are sorted. Now we look at index 3 and 4, 37, and 29. Then the smallest is 29. So we swapped 19 with 77. And the array now is 10, 14, 14, 29, 37. And now, hooray, we get a sorted list from smallest to the biggest. So that's how we do selection sort. And you might wondering how efficient it is. The time complexity of selection sort is O(n) squared, because in the worst case scenario, you are scanning the entire unsorted portion for each element you place, leading to a roughly n times n minus 1 divided by 2 comparisons. Just think about it. So for the first scan, maximally, we will scan n elements, and the second is n minus 1, and then is n minus 2, and we got to plus it to 1. So we want to aggregate 1 plus 2 to the n, and then the total time that we need to compute it is n times n minus 1 divided by 2, which is O(n) squared. So it is simple and easy to understand, but it is not the most efficient for large data sets compared to more advanced algorithms like quicksort or merge sort. However, it only takes at most n minus 1 swaps, which can be advantageous in certain scenarios. Okay, so I've explained with an example. Now this is the high-level understanding of the selection sort. So it works by dividing the list into two parts: a growing sorted portion at the front and an unsorted portion that makes up the remainder. During each process, you scan through the unsorted portion and then find the minimum element. And you swap this minimum element with the leftmost element of the unsorted portion, effectively selecting it and placing it at the end of the sorted portion. And then you shrink the unsorted portion by 1 element and repeat until the list is fully sorted. Thank you very much for listening.